So today we're going to practice drawing weighted graphs. We've discussed these in previous videos, but I've got here the definition again. But when we talk about a weighted graph, it just means a network diagram that has something that we call weighted edges. So each edge has some kind of quantity or numerical value associated with it. Here they've got examples of cost, distance, or time. Now, we're going to do two examples today. One of them, we're given a network diagram and we want to draw basically a table that represents the same information, and then we're going to draw one of these weighted graphs from a table. Now, if you see here, we have our network diagram on the right, and I've got my little table down the bottom here where I've written all of my vertices here, and all of these cells in my table represent the weighted edges of the graph. Now, as you look at it, you're going to notice a couple of things. Now, the vertex A obviously doesn't connect to itself, or there's no real loop. The same thing goes for all of these. So these cannot be connected with weighted edges because it's just the same vertex corresponding to the same vertex. Now, once we look at the weighted edges here, we can look at filling in the remainder of these cells. Now, if you look at the connection from A to B, this has a weighted edge of 9, so that will go into this cell here. If you go from A to C, we can see that there's actually no edge connecting A to C. So we leave this one blank, or you can draw a dash through it as well. A to D has a weight of 7, and A to E, once again, doesn't connect. Now basically, we're just going to continue on doing this until the entire table is filled out. So we have a repeat here from A to B, has a weight of 9, B to C, a weight of 3, B to D doesn't connect, B to E has a weight of 4. Moving on, A to C doesn't work, B to C is 3 again, C to D has a weight of 6, and C doesn't connect to E. Now, you can put these dashes or you can leave it blank, whatever you would prefer. But you should start noticing as well, as you draw this table, you see a nice little mirroring effect, which will make it a little bit easier to work with as well. D to C has a weight of 6, and D to E has a weight of 5, and almost finished. B to E has a weight of 4, C to E doesn't have anything, and D to E has a weight of 5. So we're basically just looking now, just really simply matching up what we see over here at the top and writing it in a table form. This basically condenses the information, and it lets us to read through this information and just represent it as a table where it summarizes the information. Now, if we move on to example 2, you can see here that we have a table and we are drawing our network diagram from this. Now, you can see here in part A, it's saying what will be the vertices of the network diagram. They're just given to us in the table. So the vertices we're looking at is everything from A on to G. So A, B, C, D, E, F, and G. Now, just to give you an idea of how the second one will look, I'll give you a chance to sort of have a go at these on your own if you want to pause the video, but it's saying what will be the values of the weighted edges in the network diagram. So the weighted edges are, or the values of those, are these numbers in the actual cells. So this number here, 32, means that the weighted edge AB will have a weight of 32 units. The weighted edge of, for example, AC is 15. Now, I won't do this for all of them because A, it'll be really time consuming. And this is basically just to give you a gist of how we can read off the weighted edges from this particular table. Now, part C is asking us to draw a weighted graph to represent the information in the table. Now, I've drawn up the vertices here. We just want to practice looking over at this graph and then making the edges, putting all the information from the table into our graph. Now, A doesn't connect with A, obviously, but we move along. I'll start with this first row. A to B has a weight of 32, so we're drawing a line that connects this, and we're labeling it here. A to C has a weight of 15. We draw this in. So I'm just going to tick these off as we go. A to D has a weight of 20. And A doesn't connect to E, F, or G. That's what those dashes are basically telling us. Now we've already labeled this 32 here, and we want to move on from B to C. We see it has a weight of 30. So we're just drawing our edges and we're just writing the weights next to them. And B connects to F, has a weight of 18. We've done A to C already. We've done this one already. C to D. C connects with E, which has a weight of 53. And C connects to G, and that has a weight of 24. Moving on, we've already done this one, and you can see, like I said before, a lot of these mirror. So we basically don't have to do them again because we've already done the edge. Now D to E is going to be 42. Everything else here we've done already. E to G this time will have a weight of 45. 18's already there. F and G is 47. And everything else we have already done. So we are just working through these, and here we have our final network diagram. We're basically writing something that corresponds to this. Now, if you've paused the video and you've had a go at doing it on your own, you may have gotten a different network diagram to me. So it may have looked a different type of way, but as long as you've labeled the edges correctly and you've drawn them in, you've written the corresponding weight correctly, that is all good. Remember, with network diagrams, there are numerous ways to represent the same information. These are those isomorphic equivalent graphs that we've spoken about in previous videos. Now, part D is just asking us what is the total of the weighted path from A to E via B, C, and G. So let's actually just find this path. We're starting at A and we're trying to get to E, and we're getting there via B, C, and G. So I'm drawing my path here to B, to C, and then G. So I've gone through here, B, C to G, and I have to end at E. So this is the path that I've drawn in. To find the total weighted path, we are just going to add all of these weights together, and I've done that already down the bottom. So we add our paths, our edges of 32, 30, 24, and 45, and that gives us a total weighted path of 131 units. Remember, these units can represent anything. We had in the key ideas, these represent cost, distance, or time. That brings us to the end of this one. We can draw now weighted graphs using a table, and we can also draw a table given a particular network diagram. Thanks so much for watching. I'll see you next.